Today we're going to talk about trigonometric word problems and how to go about solving them. In short, guys, the way of solving word problems is, you can break it down into 3 steps. The first thing I do is identify important information that's given. From that, I will then draw and label my right triangle. From there, I choose the correct trig, equation, and solve via Desmos. All right. So question number 1, I have sides of a rectangle are 25 and 8. What is the measure to the nearest degree of the angle formed by the short side and a diagonal of the rectangle? So again, I want to identify my important information. So I have sides of a rectangle are 25 and 8 centimeters. Something else is measure to the nearest degree, and the key thing here is the angle formed by the short side and diagonal. All right, so if I think of a rectangle, the long side is 25, the short side is 8, and the diagonal, just goes from one corner to its opposite corner. And from here, I simplify this picture, and I have 2 right triangles, one that looks like this or one that looks like this. Which one we use, it doesn't matter. So me personally, I'm going to use the one that was on the left. Reason being is that's what we're most oftentimes seen picture-wise. Now, what I'm actually solving for this time is solving for an angle formed by the short side and a diagonal of the rectangle. So the short side is 8, and the diagonal, so I'll actually want theta or x. All right, so now again, my hypotenuse, now I'm into labeling my triangle. Hypotenuse, always across. I don't know it, don't have any information about it. Then find theta, or what I'm solving for, which is x. Remember, when I trap x with this arc, it always hits the adjacent side, forcing the remaining side to be my opposite, which happens to be 25 in this example. And again, psi, ka, toa. Because I cross out my hypotenuse, because I don't have it, don't want to find it, I'm left with toa. So it's going to be tangent of theta equals opposite over adjacent. And from here, I just plug everything in. So I have tangent of x, y equals tangent x, y equals opposite, which was 25 over 8. Go to Desmos. make sure my calculator's in degree mode because I'm doing trig. And from here, you just type in your system. Y equals tan of x. Y equals 25 divided by 8. And again, when you're solving for angles, you're going to need to zoom out quite a few times. And so if I continue zooming out, click here, I can see 2 dots. Now, something very important, in trig, your answer will always be positive, or in math 2 anyways. So 72.25 is going to be my answer. Remember, solution to a system is the x value at which your graphs intersect. So 72.25. Or if you want to round it, you could go 72.3 or 72. All of these are degrees. It'll just depend on where it tells you to solve from, or where to round to. Here I have a kite flying 115 foot above the ground, so that's going to be important. The length of the kite string is 150 feet, measured from the ground. Find the angle. So if I think of flying a kite, have a kite up in the sky, you just attach a string to it. If I go directly below it and then you stand on the ground, I have a picture like this. Again, I take this, I simplify it to the following picture, and now I just plug in things. 115 foot directly above the ground. The length of the string is 150. Find the angle that the string makes with the ground. So here, again, solving for theta, not a side. Label my triangle, starting with hypotenuse, which is 150. From there, theta, x. When I trap x, it touches the adjacent, and the hypotenuse, I don't know it, don't want to find it, forcing my remainder to be 115, or my opposite side to be 115. From here, I write out my 3 trig equations. Because I didn't want adjacent, I cross out everywhere I see an A, and I get rid of those equations. I'm then left where I can set up my system. So y equals sine theta, which is really x, and then y equals opposite over hypotenuse. Once I go here, I go to Desmos. When I start a new problem, I zoom in. And like I said, if you're going to be finding angles more times than not, you're going to have to zoom out a little bit. I get x equals 50.055 degrees. And again, depending where you want to or are asked to round is what your answer will be. I'll do one more that'll have a solving for side. Observation tower 75 meters high. So if I think about a tower, and I say it's 75 meters tall, a support wire is attached to the tower 20 meters from the top. So it doesn't go all the way to the top, but just a little bit. If the support wire and the ground form an angle of 46 degrees. Then what is the length of the support wire to nearest tenth? So X. Now, remember, this problem is one of the tougher ones in my opinion. Reason being is because we're not going all the way to the top of that 75. If you've taken any trade classes, being able to read a blueprint will help you tremendously here. So if this is 20, the entire thing is 75. That means this piece is 55, which I'm going to use. So my triangle really has these values. X, 46, and 55. Because of that, I'm going to delete what I had. Again, label triangle X. Theta this time is 46. Immediately find my adjacent side, which, remember, when I track my theta, it touches the hypotenuse, which was X. The adjacent side I don't have information about, nor am I trying to solve for it. That leaves my remaining side to be the opposite side, which happens to be 55. From here, my trig equations. Because I cross out adjacent, I get rid of the cosine and tangent equation. And I have y equals sine theta, which is 46. Y equals opposite, which was 55, over the hypotenuse, which is X. Once I do that, I just go to Desmos. Y equals sine of 46. Y equals 55. Divide that by X. Whenever I start a new problem, I go home. I'm only concerned about positive X values, but I can see I need to go to the right. My answer is the X value where they intersect, which is 76.459. And I want to round, very important here, to the nearest tenth. So the 9 is going to have 0 influence. That 5 forces that 4 to become a 5. Oops. And use the correct unit of measurement. 76.5 meters.